This is Andy Whittle from HowEFIWorks.com, and today I'd like to do a little presentation on why we do high-speed data loggings to help troubleshoot what might be going wrong on a engine miss. This is a log that somebody brought to me or showed me and asked me to help him with his car. He was complaining that the car was a hard start. If you notice, the font may be too small, but down at the bottom, this range right here is about 17 seconds. That was what it was taking for the car to catch and start running, from the time the starter was energized till the time the car was running. Down on the left, I've got RPM and map. That's in the top section. So map is in red, RPM is in white. The next log down, or next trace down, is lost sync errors. And as you can see, constantly this motor was rising with new lost sync errors. So that was the starting problem, is the motor was having trouble catching RPM. If you notice, the RPM is all over the place. At one point, it completely loses RPM, comes back, and then right here, the motor fires and runs. Down at the bottom, you can see a constantly climbing time. So obviously the ECU did not lose power. At the very bottom, we've got pulse width. If you notice, it was running about 2 milliseconds of pulse width. At one point, it actually dropped out to 0 pulse width and then went ahead and fired. So let's see what high-speed data logging will do for you to help troubleshoot this problem. This is a cam and crank log, which shows up as a composite log. Cam and crank is a special logging version we have that shows all the edges of the crank teeth in this bluish color. In the green is the cam sync, and at the bottom is everywhere the code determined it found a edge of one of the teeth. If you notice, this is a 36 minus 1, but the minus 1 is showing up here and over here. You can also see the teeth are very close together, meaning higher speed. And then as the motor starts pulling through compression, the missing tooth shows up. Well, the problem was the missing tooth was too difficult for the code to find and often missed it. So in this particular case, we cut off a second tooth off of his 36 minus 1 to make it a 36 minus 2 and made the missing tooth far more obvious for the code to find. Here's a log of a similar 36. Now, this is a 40 and a 40 tooth. This is a log of a 40 tooth crank wheel, even spacing, and on the cam, a single tooth. Again, in this case, we're doing a composite log, and you can see very close teeth, and then they get wide, very close and wide. That's what you'd expect on a high compression motor, but for some reason, these in a composite log will only show up when it's lost sync, and we lost sync somewhere in this area right here. So I zoom in to that very area, and sure enough, you can see multiple teeth being read, essentially from static or noise. And that was the problem, is the code was finding extra teeth. In this particular case, I added filters. You can also play with, on the old MS3X type systems, you can play with the potentiometers in the code. Here's an example of a motor that was a pure 36 minus 1, so it would have been in wasted spark. I can tell that because at the top, there is no cam sync. And at the bottom, for the most part, we're getting a consistent, every 36, 35 teeth and then one missing, 35 teeth and then one missing. But look right over here. Another tooth or two possibly came up missing. That's an indication that maybe the crank sensor was a little too far from the crank teeth, or something else was going on. But that was his lost sync problem right there. We also have a tooth logger. A tooth logger uses the time between two teeth to draw a bar. In this case, the highest bars are about 12 milliseconds, and it gets down to about 7 milliseconds. These bumps you see are compression strokes as the starter motor attempts to pull the crankshaft up through the compression. Here we probably had the fuel injectors turned off, so you were just seeing the motor pull through the compression. Tooth 1 is the first tooth after the missing tooth, and it is roughly twice as tall. If you notice, there's about 12 milliseconds and about 7 milliseconds, and it goes to about 14, as you'd expect. Here's tooth 5, 10, 15, 20, 25, 30, and 35, but notice tooth number 36 never really showed up, so it showed up as a tooth 1 is long. This is a textbook what it should look like on a 36-1 high compression motor, where the missing tooth is where the starter is having an easy time pulling through. Here's an example of a V8. The reason I can tell that is between the two tall teeth, 360 degrees of crank rotation, there's 1, 2, 3, 4 cylinders. This pattern would go on and repeat. But that's pretty much what it should look like. This cylinder right here may have a little more compression than the other cylinders for some reason. Here is the same V8 motor, but what he has is the VR sensor is wired backwards. So what's happening is the VR is having trouble, or the code is having trouble reading the VR as it's not stepping to low voltage. So what I'm getting is two reads, two different teeth. That will confuse the code. Literally all we did on that test was the previous motor, and we swapped two wires on the VR sensor. By the way, VR is variable reluctor. Here's a motor that it turns up had the same problem. Notice that there's two teeth instead of one, but also, assuming that again it's cranking with no power to the coils or injection, notice how it's having trouble pulling through this cylinder, and then this cylinder has almost no compression. This one's down on compression, and they progressively get higher. So not only does he have a VR miswired, he has a serious compression problem. Thanks. I want to thank all my friends at tunerstudio.com. These are the guys that developed Mega Log Viewer HD, the version I use for viewing all these graphs, and Tuner Studio, the software that tunes the MS family of ECUs. DIY Auto Tune, which supplies all these cool parts and pieces, sensors and all, plus the MS Pro series of ECUs. And most of us hang out at msextra.com, where I can be found as Whittle Beast. Thank you for watching.